Now we will do some questions from DCF, discounted cash flow applications. The first question is, which of the following statement least accurate? Accurately describe IRR and NPV methods. Before solving the question, we should know what is NPV and IRR. IRR is a point where NPV is 0, and most of the time NPV, positive NPV, will be a decisive point. So if we see B option, that is, if NPV and IRR methods give conflicting decisions for mutually exclusive projects, the IRR decision should be used to select. This is the least accurate because NPV is the decisive factor. So if you see NPV and IRR methods gives conflicting, so always select the project with the great positive NPV. You will see other option, discounted, that gives an investment in NPV of 0 is investment IRR, it's okay. NPV method assume that project cash flow will be reinvested the cost of capital, while IRR method assume they will be reinvested at IRR. This is how it moves. So B is the right answer. Which of the following statement least accurately describe the IRR and NPV methods? So if you see the C option, a project NPV may be positive even if IRR is less. This is not possible because NPV is 0. It's a point where IRR is a point where NPV is 0. So a project will have a negative NPV if it is IRR is less than the firm cost of capital. So project NPV may be positive even if the IRR is less than the cost of capital. This is not possible. The other option, a project IRR can be positive even NPV is negative, is okay. A project with an IRR equal to the cost of capital will have an NPV of 0. That is obvious. So C is the right answer, which is least accurate information. Which of the following statement least accurately describe the IRR and NPV method? So if we see NPV tells how much the value of the firm has increased if you accept the project. It's true. When evaluating independent projects, the IRR and NPV method always yield the same acceptance rejection because of independent projects which are not dependent on each other. And if you see the C option, when selecting between mutually exclusive projects, the projects with the highest NPV should be accepted regardless of the sign of the NPV calculation is wrong, because when selecting between two mutually exclusive, either project should be accepted if they both have a negative NPV. We'll do another numerical question. A company is considering entering into a JV that will require an investment of 10 million. So 10 million will be your outflow in year 0. Project is expected to generate cash flow of 4 million. This is CO1. CO2 is 3 million. CO4, this way onwards it will go. CO3 will be 4 million in each of the next 3 years respectively. Applying a discount rate of 10%, we have to calculate the net present value. It's a very interesting topic, question, and we will use a financial calculator for it. How to solve this question? This is we previously discussed. I will do it again. First of all, you press CF button, then the second button, and the clear work, that is going to clear all the memory within the question. So I will start putting the data. I press CF. Now I will put 10, then press minus because this is the outflow, and then I am going to put enter. Then I will put this arrow sign down. This is CO1, that is the then we have an inflow, that is 4 million, so I will enter 4. Then I will enter then I will show arrow sign 2 times. Then I can put CO2, that is 3 million. 3, enter. I will press 2 time arrow sign, and then it will be CO3. Then it is the 4 million. 4 million is enter. Then I will press 2 times this one. Okay, now once I press enter, I will put NPV, and this NPV I have to put the discount rate, that is 10%, and then I will enter this way, and then I will say compute. So I get a present value of 0.8790. That is the 0.8790. That is the A answer. So this is how you enter your data, and once this, I will clear this all, so there should not be a problem. This is how we do the calculation years. A company is considering entering into a JV that it requires it's the same question. It says, assuming a discount rate of 10%, what is the project appropriate IRR? So it's the same question, just we have to press another button to calculate IRR. For that, just for the practice sake, we can enter the data again, so it will be a further practice for you. Although it is not required, you can use the storing functions in the calculator. That is pretty handy and smart. So you will have 4 million, this is 2 times, then you will press 3 million, again enter 2 times, and the last is 4 million that you have to press 2 times, and you will enter, and then you will press IRR, and where IRR is here you have to put the discount factor. So here I will put this compute, and this is 4.92, so that is the right answer. You can round off, so it will be 5%. Okay, let's move forward to another question. What should an analyst recommend based on the following information for 2 independent projects? When independent projects are not dependent on each other, so whatever is the good one you can choose for according to your calculations. There are 2 projects. You have to invest 3,000 in A and 10,000 in B. Cash flow at 1 is 5,000, A 15,000. IRR is A is more and present value for B is more, while IRR of B is less and present value for project A is less. A has given some option: accept A and reject B, reject A and accept B, or accept A and accept B. So according to the knowledge, if there are independent event and both have positive NPVs, you don't have capital rationing issue, there is no money problems, you have unlimited funds. So in independent, if both are positive, you can go for it. Both projects should be accepted since both projects has positive NPV and will increase the shareholder values. What should an analyst recommend based on the following information for 2 mutually exclusive projects? It's like you invest 3,000, get 10,000, so it's almost the same. Just information changes mutually exclusive projects. He says when NPV and IR ranking conflict, always select the project with the highest positive NPV in order to maximize. So you can see the project B has highest NPV, so we will accept project B and we will reject project A. This is in case if they are mutually exclusive. Let's do another question. Good deal is considering the purchase of new material handling system for a cost of 15 million. The system is expected to generate a positive cash flow of 1.8 million per year in perpetuity. When we say perpetuity, this is a series for an indefinite period of time. What is the NPV of the proposed investment if the appropriate discount factor is 10.5%? So how we are going to solve this question? We have present value minus CF for 0, that is 1.8 million divided by 1.15 million, that is 0.105, minus 15 million. So this is how 2.14, 2.8 will come, and we will accept the project because NPV is positive. For solving such kind of question, we can have a shortcut. We can take 1.8 million per year in perpetuity and divide it by the rate minus the total investment. So we'll get the present value. It is positive, so accept the project. Same question, he says that what is the IRR of the proposed investment if the appropriate hurdle rate is 10.5? So how to solve this? For perpetuity, the following relation apply. We'll take 1.8 million, we will divide it with IRR, that is equal to 15 million. So we can cross reference, cross multiplication will give us this 12%. Since IRR is greater than cost of the capital, that is 10.5, accept the project. If it is opposite, then of course we will reject the process. Should a company accept a project that has an IRR of 14% and an NPV of 2.8 million if the cost of capital is 12%? So what we should do? If you see options are yes based only on NPV, yes based on NPV and IRR, and if you see no based on both, so no based on, so B is the right option because the project should be accepted on basis of positive NPV and its IRR, and it should ideally or it should must exceed the cost of capital. In this particular case, IRR is 14%, NPV is positive, and the cost of capital is 12%. Which of the following statement least likely represent the characteristics of time-weighted rate of return? So first of all, you should know what is time-weighted return. He says that money-weighted rate of return is the IRR of an investment cash net flow. That is C option is the least likely, is representing this the time-weighted, that is defined as an IRR or an investment portfolio, taking in account all inflow and outflow, which is not the case because money weighted rate of return is the IRR of an investment net cash flows. We'll do a couple of more questions for using question 12 and 13. We'll use the following data. Assume an investor purchases a share of stock for $50 at time t is 0, and another share at time 65 at time year 1 and at the time of year 1 and 2. The stock paid a $2 dividend also at the end of the year 2. So investors should sold both shares for $70 each. First he said to calculate the money weighted rate of return, that is we can easily use this financial calculator. And as I told you, for solving questions, just press CF second and clear, so it will clear your memory, then start entering. And this is, I showed you a couple of times, that you enter the word, the amount, enter plus for CO, then CO1 2 times, because frequency will come FO1, that is generally is 1. So if we enter this information, we'll get IRR, that is 18.02. Now the time weighted rate of return on investment is what? So if you put it in the formula, C is the right answer, because the HPR is 65 plus 2 divided by 50 minus 1 is 34, and the for other is 140 plus 4 divided by 130 minus 1, that is 10%. And if you put in the formula 1.34, that is here, and 1.077 times 0.5 minus 1 is 21.83. In terms of time weighted returns, you just have to plug the formula and get the right answer. What is the bank discount yield for T-bills? That is selling for $99,000 with a face value of $100,000 and 95 days remaining until maturity. So take this 1,000 divided, the difference of this is 1,000 divided by the total into 360 days divided by the 90 days. So your correct answer is 3.79. This is just an application of the formula. What is the holding period yield for a T-bill that is selling for $99,000 if it has a face value of $100,000 and 95 days remaining until maturity? So take the total value minus the selling price divided by the selling price. You will get 1.01. That is the effective answer, 1.01. What is the effective annual yield for a T-bill that is selling for $99,000 if it has a face value of $100,000 and 95 days remaining until maturity? Put the formula, 1 plus the rate, 365 is the year day and 95 is the effective minus 1, so 3.94 is the right answer for such kind of questions. What is the money market yield for a T-bill that is selling for this? So this is the same question. It's just asking about money market yield. You should know the formula. We'll take 360 multiplied by 0.0379 divided by 360 minus 95. That is the period, and this is the return 0.0379. So it will give you 3.83. Which of the following is least accurate regarding a bank discount yield? The first option, it ignores the opportunity to earn compound interest. B is it is based on face value of the bond, not its purchase value, which is true. C option is it reflects the non-annualized return an investor will earn over a security life, which is least accurate about bank discount yield. It's actually the definition of the holding period yield. Move forward, let's do 19th question. A 175-day T-bill has an effective annual yield of 3.8. Its money market yield we have to calculate. It's very simple. 1 plus 3 is 1.038, and then we have 175 days divided by 365 minus 1, so we can calculate 1.08. That is the right answer. For such kind of question, you can quickly use the effective annual yield, and all information is given. We have some challenging questions and at least some Rogers CFA makes the following statement. He says the problem with the bank yield quoted for T-bill is that they are not yields. They ignore compounding and they are based on a short period, short year. So A option is she correct in all respects. So we can say yes, she is correct in all respect. Bank discount yields are not true yields because they are based on a percentage of the face value instead of the original amount invested. They are annualized without compounding, since the actual discount from the face value is simply multiplied by the number of periods in a year. The year used is 360, so it is a shortcoming as well. B option is which of these problems are remedied by using the holding period yield. So he says the holding period yield use the increase in the value divided by the amount invested with the purchase price. So it solves the problem that the BDY is not a true yield. C, he says which of these problems are remedied by using a money market yield. So he says money market yield is also a true yield, that is a percentage of initial investment, but does not solve the other two problems since it does not involve compounding and it is based on 360 days a year. So for solving this question you should have a sound knowledge of all these four options. D, which of these problems is already remedied by using effective annual yield. So effective annual yield solve all these shortcomings based on the holding period, that is a compound annual rate, which as we saw that it is daily, monthly, quarterly and semi-annually. Let's do another question, that is a retirement. 9 years from now a client will have the option of receiving a lump sum amount of 400,000 or 20 annual payments of 40,000 with the first payment made at retirement. What is the annual rate the client would need to earn? A retirement investment to be indifferent between the two choices. So we can do in two ways. Easy way is, let's shift your calculator in a beginning mode. You have a present value of 400,000, period is 20 years, future value is 0, and the steady payments will be 40,000. And he says that 2 annual payments of 40,000 with the first payment made at retirement. If you calculate IY, you will get a rate that is 8.9. So you can calculate, setting the retirement date as he did is 0, 1, 2 and 19 year, it will be this way. One method is present value 400 minus 40, 360, series of payment minus 40 and is 19, future value is 0, compute way. So the both ways you can solve this question. This is the end of our discussion.